This is a motor single-line diagram. The whole motor circuit drawn as one clean line from the incoming supply all the way to the motor itself. If you have ever sized a motor feeder, built a starter panel, or booked an inspection, this is the drawing at the center of it. One page, the whole starter chain, every protection device, the way the power actually flows. So let us rewind it and build this motor single-line diagram up block by block: supply, breaker, isolator, contactor, overload, motor, so that by the end you can read one at a glance and draw your own. First, why this drawing exists at all. You may have seen a generic single-line diagram before. One line standing in for all three phases of a system. This is that same idea, aimed at one job, a single motor feeder and its starter. And it earns its place. It does three things. It sizes the feeder, the cable, the breaker, the contactor, all matched to one motor. It sets up protection coordination, so the breaker, the fuse, and the overload trip in the right order, not against each other. And it is the drawing your panel schedule and your inspection are read from. That is the promise of the motor single-line diagram. The entire starter, honest and complete, on one readable page. So let us follow the power. Here is the whole chain, left to right, the way the energy travels. It starts at the incoming supply, the bus bar the feeder taps off. From there it runs into a main breaker or a fuse switch for short circuit protection. Then through a line isolator, a switch you can lock off. Into the contactor, the switch that actually starts and stops the motor. Then the overload relay, guarding the windings. And finally the motor itself. Every block on that line has one job, and its own protection or control device. Learn the chain, and the whole diagram opens up. Let's take it one block at a time. Quick note before we do. Every symbol in this video lives in a free editor that runs right in your browser. CircuitDiagramMaker.app. No install, no sign up. Open it in a second tab, and you can drop these same blocks in as we go. The link is below. Block 1, the incoming supply, and the main breaker. On the left, the feeder taps off a bus bar, your three-phase supply at the panel voltage. That is the source of the whole drawing. Right after it comes the main protection, a circuit breaker or a fuse switch sitting across the line. Its job is short circuit protection. If a fault dumps huge current, this is what clears it. And its rating goes right on the page because everything downstream has to coordinate with it. Supply, then breaker. That is where the line begins. Block 2, the line isolator, sometimes called the disconnect. This is a switch whose only job is to completely cut the motor circuit off, so anyone can work on it safely. On the diagram, it is a plain switch symbol on the line, rated to break the load current and to lock in the off position. The breaker protects, but the isolator makes safe, and they are not the same device. You will often see this isolator mounted local to the motor, so whoever is servicing it can kill the power right where they stand and padlock it there. Isolate to make safe. It belongs on every motor one line. Block 3, and the heart of the whole thing, the contactor. The contactor is an electrically operated switch, the device that actually starts and stops the motor. On the single-line diagram, it is drawn as a switch with a small arc on the moving contact, and that arc is how you tell a contactor from a plain switch at a glance. Two things matter here. It is AC3 rated, which means it is built for the heavy inrush current a motor pulls at start, not just the steady run current. And it is coil-operated. A control coil pulls the power contacts closed. That coil is a whole little circuit of its own, and we will tap it off in a moment. For now, contactor, the switch that makes the motor go. Block 4, the overload relay, thermal or electronic. The overload sits directly under the contactor in the same run of the line, and it does one thing. It watches the current and trips if the motor pulls too much for too long. On the diagram, it is a small block with a thermal element inside it. Here is the part people get wrong. The overload is not short circuit protection. That was the breaker's job. The overload guard against a slow, sustained overcurrent, a jammed load, a failing bearing, a lost phase. And it is set to the motor's full load current, the FLC, so it protects the windings without nuisance tripping on a normal start. Breaker for faults, overload for overloads. Two different devices, two different jobs. Block 5, the motor, the load the whole drawing was built around. On the single line diagram, it is the classic symbol, a circle with a capital M inside, marked 3-phase. Simple to draw, but next to it you write the two numbers that define the entire feeder. The motor's rated power, its kilowatts or horsepower, because that is what sized the cable and the contactor in the first place. And its full load current, the FLC, the exact number you just dialed the overload to. Get the motor's kW and FLC on the page, and every device to the left of it suddenly has a reason for its rating. Now, one branch we have not drawn yet, the control transformer. Everything so far has been the power circuit, the heavy line that actually switches the motor. But the contactor's coil needs power too, and you do not want that coil sitting at the full line voltage. So a small control transformer taps off the line side and steps the voltage down, often to 110 or 24 volts, to feed the coil safely. On the single line diagram, you show that tap dropping off the main line into the transformer, and the transformer feeding the contactor coil. Power circuit up top, switching the motor. Control circuit underneath, at a lower, safer voltage, energizing the coil that closes it. Two circuits, one drawing. One more thing the one line has to tell you, how the motor is started. Because the block between the isolator and the motor changes shape depending on the method. Direct online. The chain we just drew is the simplest, one contactor, one overload, and the motor is thrown straight onto the full supply. Star-delta swaps that single contactor for 3, a main, a star, and a delta contactor, to start the motor softly in star, then switch it to delta to run. On the one line, you draw the 3 contactors so the reader knows. And a soft starter or a VFD replaces the contactor and overload with a single electronic block. And a VFD also sets the motor's speed. Same motor, same supply, but the starter block on the drawing tells you exactly which method is in that panel. And running underneath all of it, earthing and bonding, the part beginners skip and inspectors never do. Every metal part that should never be live gets tied to earth. The motor frame, the starter panel, the isolator enclosure, all bonded together and connected down to the earthing system. On the single line diagram, this shows up as a green earth line reaching every block. Equipotential bonding just means all that metal is held at the same potential, so there is never a dangerous voltage between two things a person might touch at once. It is the quiet safety net under the entire drawing, and on a motor one line, it is not optional. Draw the earth every time, so step back and look at what you have. Standard symbols in a standard order. A bus bar for the supply, a switch with a cross for the breaker, a plain switch for the isolator, a switch with an arc for the contactor, a little block for the overload, a circle M for the motor, 2 circles for the control transformer, and earth reaching all of it. That is the whole language of a motor single line diagram. And it is exactly why the drawing exists, because anyone who knows these symbols can pick up your page and read the entire starter without ever opening the panel. That is what the panel builder works from. That is what the inspector checks. And that is what protects the people who service it later. Let us recap the line. Supply, off the bus bar. Main breaker or fuse switch with its rating. A line isolator to make it safe. The contactor, the coil-driven switch that starts the motor. The overload relay, set to the motor's full load current. The motor itself, with its kW and FLC. A control transformer tapping off to the coil. An earth bonding all of it together. If you want the ground level basics of single line diagrams first, what one line and 3 phases really mean, watch our single line diagram tutorial, linked right here. And if you're building the starter itself, the contactor, VFD, and motor control adder videos take it further. Then open the free editor, drop in the supply, and build your own motor single line diagram. The link is below. Subscribe for a new diagram explained every week, and I will see you in the next one.